Our last lesson of the year, to construct and use two-way tables. So here we have a two-way table, two ways because the rows add up to a total and then the columns add up to a total. And some of the blanks here, they're unknown. We need to figure them out. Like boys that prefer skiing is 18 and the total is 38, so the snowboarding must be 20 because 38 minus 18 is 20. And then if 20 boys prefer snowboarding and 6 girls prefer snowboarding, that's a total of 26. And now we can back into the total number of people that prefer skiing by subtracting 26 from 60. So that gives you 34. Now you can figure out the number of girls. You don't have to go in the same order that I did. You probably could have started with this one and worked backwards, but eventually you'll figure out all the unknowns. It's not as tough as a Sudoku puzzle, but you get the idea. Now, what percent of the students are girls that prefer snowboarding? Okay, so we're only looking at the girls. No, what percent? I take that back. What percent of the students? There are 60 students. How many of those are girls that prefer snowboarding? So 6 girls out of all 60 students. So that's going to be 10%. What percent of the girls prefer snowboarding? Now this is what I was originally thinking. There's only 22 girls. What percent of those prefer snowboarding? 6 out of 22. That's a completely different question. You really have to read these questions very, very carefully. Okay, this one says what percent of the students. So that's why the denominator was 60. This says what percent of the girls. We're only 22 girls. Very different question. Okay, so what percent of the students are boys? So percent of students, our denominator is going to be 60. What percent are boys? So I'm going to say 38 out of 60, right? That makes sense. 63%. What percent of the boys prefer skiing? So we're only looking at the boys, 38. What percent of them prefer skiing? 18 out of 38 makes sense. What percent of the students are boys that prefer snowboarding? So what percent of the students? There's 60 students. What percent of those are boys that prefer snowboarding? So I'm going to say 20 out of 60. And what percent of the boys prefer snowboarding? What percent of the boys? So 20 out of 38. Different question. Tricky. So you might want to pause the video here, see if you can complete the table. So the first thing I'm going for, probably the only thing you can do, is figure out the total number of people that have decided on their college of first choice by subtracting 45 from 80. Now you can figure out the number of juniors because the juniors plus the seniors has to equal the total. 35 minus 23 will be 12. And now you can work across. 12 plus 28 is going to be 40. You could do subtract here or subtract here. It doesn't really matter which one you do first. If this is 40, 23 plus what equals 40? 17. And make sure that it also works down. 28 plus 17 equals 45. So there's your two-way table. Now, let's answer a few questions. What percent of the students are juniors that already decided on first choice? So, percent of the students. Okay, so 80 is our denominator. And they're juniors that have already decided. So 12 out of 80, 15%. What percent of juniors had not yet decided? So just the juniors, percent of juniors have not, so 28 out of 40. And then a few more questions. What percent of the students are seniors that already decided on first choice? So percent of students, we're talking about 80, are seniors that already decided on first choice. 23 out of 80. 23 seniors already decided on first choice out of 80 total students. So 29%. What percent of seniors have already decided? So now you're just looking at the seniors, 40. What percent of them have already decided? So 23 out of 40, 58%. So here we see a little bit larger two-way table, but it still has totals on the horizontal and the vertical. So it's no different, just a little bit bigger chart. I guess it's a survey about a dress code. Where should we start here? We could figure this out, this out. There's a lot of places you could start just figuring things out. If we subtract 304 and 81 from 420, we see that this has to be 35. And then this one has to be 20 because these three add up to 448. We could figure this out. 12 plus 5 plus 3 has to be 20. These adds up to 15. 15 from 20 is 5. We could figure this one out or this one out. And you just basically complete the chart. And then make sure that it works in all directions. You know, it works horizontally and works vertically. And then we'll answer a few questions. What is the probability that a person was a teacher given that they were against the dress code? Now, this is worded really weird, and even weirder is the notation for it. The probability they were a teacher given they were against the dress code. This vertical line here means given that. So we're just looking at people that were against the dress code and how many of them were teachers. So teachers divided by number of people against the dress code, 1.6%. Okay, different problem. What is the probability that a student was against the dress code? Probability a student was against the dress code. Okay, so I interpret this as what's the probability they were against the dress code given that they were a student? It sort of flips in the wording there. But you're only looking at the students, 420. How many were against? So 304 out of 420, 72.4%. Let's try this one. What's the probability a person was for the dress code given that they were an administrator? So for given that they were administrator. So you're just looking at administrators, 8 people. How many were for? 6 out of 8. Some students have a really hard time with the wording of these. I myself get confused, so I understand how, you might have to watch this video a few times to get the hang of this. Let's look at this one. What is the probability that someone for the dress code was a student? So we're only looking at people that were for the dress code. What's the probability they were a student? So there were 99 people for the dress code. Of those 99 people, 81 were students. So I interpret this notation to be probability that they were a student given that they were for the dress code. So student divided by 4, 81 out of 99. Hope that makes sense. Okay, our last two-way table here. See if you can complete it. This one's in decimals rather than the numbers. So think of it as a percentage. We know that 24% of the men would be unlikely to buy because if you subtract 18% women from 42% total, you get 24%. Now what can we figure out? This one here, because these have to add up to 100%. So if you took 100%, subtracted 47%, you'd end up with 53. Now we can figure out what percent of women were likely to buy, because those two have to add up to 0.53. We could figure this one out now. Those add up to 0.40, so this has got to be 0.01. And now, of course, this will be 0.04. And if we add these up, these three, we get a total of 0.59. And of course, this works out. So good. Now let's see if we can answer a few questions here. How many men were likely to buy the new product? How many men? Well, we know the percentage of men is 0.31, and there were 200 people surveyed. So we're going to have to use that piece of information. So we need 31% of 200. Works out to be 62 men. Now, if they said what percent of men, that'd be 31%. But how many is a different question. What percent of people were likely to buy given that they were men? So we're only looking at the men. We could figure out the number of people, but I don't really think it's necessary. I think we could still figure this out. Likely to buy 0.31. If we just divide 0.31 by 0.59, I don't think we need to figure out the total number of men, because it just asks for a percentage. So this should work fine. How many people were unlikely to buy? So now we're back to finding a percentage of 200. How many people were likely? So 53% were likely to buy. Oh, unlikely to buy. 42% were unlikely. So 40% of 42% of 200. 84 people. What percent of women were unlikely to buy? Okay, so now we're just looking at women. So 0.41. What percent were unlikely? So 0.18 out of 0.41 is what I'm thinking. 0.18 divided by 0.41, 43.9%. And then how many women were unlikely to buy? How many women? So we're doing a percent of 200 again. Unlikely to buy 0.18 of 200. 18% of 200. 36 women unlikely to buy. What is the probability that a man chosen at random had no opinion? So you're only choosing from the men. So I'm thinking 0.04 divided by 0.59. 6.8%. Awesome. All right, we're here. The last lesson of the year. And so this is our last mistake of the day. I've been saving this one. I hope you're ready for it. So how many variables had to come into play to make this just absolutely hilarious? The name of the company, the abbreviation for assorted. I mean, I tried to see if I could buy these for everyone. And I found that they also made tasty assorted cookies. But they don't make them anymore. But how funny. All right, that's it. It's been a pleasure being your tour guide through the world of geometry. We will have a final, and I'll be posting more about that on Schooloop. So have a great one. See you soon.